Servers power everything you see online, your email, your favorite websites, the game you play, and even the videos you watch. Yet most people picture a single computer in a dark room and call it a server. That's not wrong, but it's incomplete. Servers are a mix of hardware, software, networks, and roles that work together to deliver information instantly across the world. Today I'll explain what a server really is, how it works, and why understanding servers matters even if you're not a programmer. Chapter 1. What is a server? Really? A server is simply a computer designed to provide services to other computers, called clients. But server describes a role, not just a box. The same physical machine can act as a web server, a file server, or a database server depending on the software it runs. Servers are optimized for reliability and availability. They are built to run continuously, handle many requests at once, and restart gracefully if something goes wrong. Unlike your laptop, servers expect constant demand and are designed with redundancies to keep services online. Chapter 2. Hardware versus software. Two sides of the same coin. On the hardware side, servers often have powerful CPUs, lots of memory, fast storage, and multiple network interfaces. They're usually rack-mounted in data centers with controlled power, cooling, and physical security. That physical environment is part of what makes a server reliable. On the software side, a server runs a piece of software called a server application. For example, a web server application listens for HTTP requests and responds with web pages. The operating system, drivers, and server software together decide how to handle incoming work, how to use hardware efficiently, and how to keep data safe. Chapter 3. How servers communicate. IP addresses and ports. Servers communicate over the internet using IP addresses and ports. An IP address is like a street address for a machine. A port is like a specific door at that address. Each service listens on a different port number. When your browser requests a web page, it sends packets to the server's IP address and the web server's port. Routers and switches move those packets across networks until they reach the right data center. The server then processes the request and sends the response back. This whole round trip usually takes milliseconds. Chapter 4. Handling many requests. Concurrency and load. Popular servers handle thousands or millions of requests every second. They do this using concurrency, multiple threads, processes, or asynchronous I/O to work on many requests at once. Load balancers distribute traffic across multiple servers so no single machine becomes a bottleneck. When demand spikes, like during a product launch or viral video, systems scale. Scaling can be vertical, giving a server more power, or horizontal, adding more servers. Modern cloud infrastructure makes horizontal scaling easy, allowing services to expand or shrink automatically based on real-time demand. Chapter 5. Storage and databases, where data lives. Servers store data in files or databases. File servers keep documents and media. Database servers organize structured data and answer queries quickly. Databases use indexes, caching, and query optimization to return results fast, even on huge datasets. For reliability, servers often replicate data across multiple machines. If one server fails, another takes over. This replication, combined with backups, ensures data is available and not lost when hardware breaks or an error occurs. Chapter 6. Security and access control. Servers are prime targets for attackers because they hold valuable data and services. Security starts with basic hygiene, strong passwords, up-to-date software, and firewalls. Beyond that, servers use encryption to protect data in transit and at rest, and access controls to limit who can read or modify data. Logging and monitoring help detect suspicious activity. If a server behaves strangely, too many requests, odd patterns, or failed logins, security teams investigate and respond. Good server management is as much about preventing problems as it is about reacting to them. Chapter 7. Virtualization and the cloud. Servers as services. Modern servers are often virtual. A single physical server can host many virtual machines or containers, each running its own operating system and services. This improves utilization and isolation, so different applications don't interfere. Cloud providers expose servers as services you can rent on demand. Instead of buying hardware, you request a virtual server from a provider, configure it, and deploy your application. This model changed how software is built and scaled, making it possible for startups to run global services without owning data centers. Chapter 8. Why servers matter to you. You don't need to become a server admin, but understanding servers helps you grasp how the internet works and why outages happen. When a website is slow, it's often a server, network, or database issue. When your data is safe, it's because servers are correctly configured and monitored. If you want to get into tech, learning how servers work is a high-impact skill. It's the backbone of web development, cloud computing, data engineering, and cybersecurity. Final advice: start simple. Rent a tiny virtual server, install a web server, and host a basic site. Experiment with storage, run a small database, and learn how to monitor logs. Practical experience teaches more than theory. Servers are powerful tools. Learn to use them responsibly and they'll open many doors. Disclaimer: this video is for educational purposes only. It explains server concepts for learning and does not provide instructions for illegal activity. Always use your technical skills ethically and legally.